Hello, and welcome to another episode of the Atomic Podcast. I am very privileged and happy to be here with Dejan Markovic, and he is a professor of electrical and computer engineering at UCLA. He runs a very large department, but more importantly, I want to tell you a little bit about, and then I'll turn it over to Dejan for his background. But I want to tell you how I met Dejan because I think this is important. For today's episode, we're going to be talking about uh, screen time and digital technology and AI, and how that has, in essence, partially captured the attention of our children and our teens, and how that's actually evolving in terms of relationships, in terms of intimacy, in terms of how children actually see not only themselves and their self-image, but also how they actually see time and bring focus to certain projects. And so we're going to be talking about children and teens. But how I met Dejan is I met him at my daughter's school, and he gave really an outstanding presentation on one level, the cognitive neuroscience, but the technology that has been yoked together to create basically the attention economy that has really focused down in monetizing, we'll call it the eyeballs and the engagement of our children, and what that's actually been doing to children. And one of the things I really loved about Dejan, one is that he's so great as a presenter, but he really brought to parents a kind of very complex technical language that they could relate to, and that they could actually see what he sees and sees what actually more and more people are seeing. The impact of these, I'll say, new digital relationships upon children's attention. And I think we all need to focus on that, because in fact that our children are the future. They are really what we want them to usher in. And as we see them develop and grow, or maybe lack some development, we want to be able to pinpoint and help them as parents to grow and to thrive. So I'm going to turn it over to you, Dejan, and thank you. I'm so happy I met you, and I'm really glad that we're doing this podcast with these topics. So give a little more background to what you've been involved in.
Thank you. It's great to be here. Real pleasure. And this topic is very important to me, both as a parent and professionally, because we all share parent experiences, and I'm deeply involved in technology development. So I'm not against technology, but I do have issue with how we use technology. I work at UCLA, and professionally I develop technologies for semiconductor chips. How can we make computer chips more energy efficient and embed intelligence? I also work in medical devices, in clinical research and neuromodulation, particularly stimulation and recording of brain cells. And through that line of work, I get to meet a lot of fascinating colleagues in neurology, neurosurgery, and get to learn from their point of view how the brain works. And that also kind of feeds into my daily life as I try to catch with my own understanding of development, and how do we practically translate that to our daily lives with our kids. So
Yeah, and I think also what's kind of wonderful to understand for our audience is some of the medical devices and some of the electrical engineering that you've actually pioneered. Maybe you can go into a little more detail there.
Sure. So on the electrical engineering, I'm trained as an electrical engineer. So I was a student at Berkeley during the just the dot-com era, Silicon Valley, building a silicon infrastructure for communications. That taught me how to think about energy efficiency. How can we do most computation with least amount of energy? Dealing with multi-antenna communications, higher data rates, lower power, more algorithms, lower power. So flexibility and efficiency are the key metrics. And then I moved down to UCLA to continue to develop my research in that area, building prototypes for energy efficient systems for future communications devices. And then I recognized another stellar opportunity, which is dealing with parallel data feeds from the brain. That's where I recognized that the size, energy requirements are orders of magnitude more challenging than in consumer applications. And I became really attracted to that area and started to develop my understanding first in about processing of parallel data recording channels from deep brain structures. How do we detect single neurons? How do we do sorting? When one electrode, you can pick up activity from multiple neurons. How do we sort which one occurred when? How do we do that in an unsupervised, more objective way? And that really inspired a whole line of work in clinical neuroscience. Then I got fortunate to be at the front line of President's Brain Initiative projects from Department of Defense, where we were tasked to update neuromodulation devices from 4 to 8 contact points, mostly recording or open loop stimulation, to more than 200 points, kind of recognizing the world of the brain, not at the level of continents, but more like countries, and having a better access, more clinical intervention points. And that's how I got involved in neurotech more than I ever thought. And then one of the interesting projects that came about 10 years ago was a proof of concept device that enabled us to do rapid seizure detection, but not looking into waveforms, but taking those waveforms, translating them into a range of frequencies that we can hear, and then using sound to detect seizures. We called it at that time brain stethoscope. Now it's transitioned to Cerebell, and it's used in more than 600 hospitals and growing. Great success, but it's also a very nice example of how we can responsibly use technology, which has this kind of built-in self-detection capabilities. People call it AI these days, but that's a very exciting example of neurotech.
From that work to the kind of flowering and maybe hype to some degree of BCI and other related efforts, how are you involved in BCI currently, and kind of where do you see that going in terms of the research you've laid already?
Yes, BCI actually started at UCLA in 1973. Professor Jacques Vidal's lab at the computer science department then introduced the term brain-computer interfaces, and he sketched out a beautiful diagram involving sensing equipment, digitizing amplifiers, and then compute with IBM 360 back in the days, feeding back into the display. And the real idea there was that you measure neural activity from the motor cortex and decode intent to be able to make a 2D navigation of a cursor on a computer screen. So that's the crux of BCI. That itself enabled us to access neural waveforms and do electrophysiology to understand motion and kinematics, but also enabled us to go deeper. So in neurosurgery, when you do intractable epilepsy monitoring with pharmacologically intractable epilepsy, you are allowed to go deeper than just the cortical recordings, all the way into the hippocampus to track the location of the seizure. And that's where you discover other networks that are really interesting, like cognition, where the networks are organized in a non-topographic way. And just having access to these deep brain structures is fascinating, trying to make inferences as to working of the higher levels of cognition. How do we go about it? And there is really many issues with neurological disorders that involve aging population and trauma and epilepsy, Alzheimer's disease, chronic pain, depression. Those are some of the key issues. And I think any technologies in that sense would need to first address front and square medical issues before we can begin to think about performance enhancements and other type of assistive learning and things at the deep brain level. There are so many issues that clinicians need to find answers for, and that's my motivation. Try to bring technology into the hands of as many people as possible to help them do translational neuroscience, to properly quantify and remedy some of these irregular brain patterns and disrupt the irregular activity to improve the quality of life of individuals who suffer from those afflictions.
And I would love to continue down this line as you and I have talked, and meaning about the translational neuroscience, but also more importantly of what this actually means for AI and what some people call superintelligence, like what this deeper cortical connection and the networks that you're able to access. For I think some people in the audience might seem scary. For others, it might seem like a sort of white horse of possibility, and for others, it might seem deeply therapeutic and super helpful. And so there's a lot of dimensions here. And one of the things that you've said is that you really are looking at technologies for wide adoption, right? And for really high impact, clinically, but also in people's everyday use. And I loved what you just said, which is, before we go anywhere, we need to also have that clinical impact, for certain diseases that are very debilitating. I super agree. I think we see our children in a way that, which is how I met you, we see our children as really certainly developing persons, and they're using many of these everyday technologies that we did not have 10 years ago, or we had maybe a very small version of it. So the work you're doing here will eventually translate into everyday use at some point. The work that you've done in electrical engineering has already translated into everyday use. So with all of that said, I'm just super interested in, when you gave a presentation at the school, what was the problem that you were identifying there? With this deep background that you have, why present that problem? What is the problem that you see with kids and teens in accessing screen time and digital and AI?
That's a great problem, and we are all figuring out productive ways to cope with it. But the crux of the problem is that our childhood has changed, particularly the environment in which now kids grow has changed. We had screens before. We were watching television as kids, but the screens that we have nowadays are different. Now we have interactive content. We have targeted, carefully developed interaction experience that grabs our attention and takes it away from what we used to do growing up, playing with friends, interacting with physical world, being creative, bored, figuring things out on our own. And now all of that is being taken away with interactive screen experience. And it's pretty scary.
And you're seeing it on an everyday level.
Yes.
And
there is even a term called electronic screen syndrome that is coined by interactive child psychiatrist Dr. Victoria Dunkley. She describes this issue, which is related to how we design our environments for childhood. And it is often exhibiting the same sort of behavioral, cognitive, emotional symptoms that some other serious medical indications do.
And what's the parallel? Meaning that some of these conditions that are born of screen time are an actual diagnosis or hides a diagnosis of like ADHD or something like that?
Yes. So sometimes kids are improperly labeled with HDAD, bipolar, anxiety, depression. And we forget to ask a question: are we diagnosing a child, or we are diagnosing an environment in which the child grows? Because any brain that is placed in a high dopamine reward cycle for extended hours per day will inevitably suffer in terms of behavior, cognition, and emotional regulation.
And how does that suffering get expressed? How are you seeing it as a parent, but also as a teacher that sees people coming in? How are you seeing that sort of express itself in everyday life?
There is several key outcomes that are manifested in clear behavioral signs. One of them is just social withdrawal. Instead of interacting with your friends, you're looking at the screen. That's number one, social withdrawal. Second one is attention fragmentation. When you're left to be bored, you have to be able to just figure things out, daydream, think about deeper meaning of ideas, as compared to the constant dopamine reward cycle when you're always something new is coming and this is exciting. And when that is interrupted, you are bored, seeking for more of that dopamine reward, which is unnatural. So that's the second issue. Third one is sleep deprivation. You need to be able to reset your brain into default mode network and your whole nervous system to relax and ease out into sleep. So digital screen, interactive screen exposure does the exact opposite. And then you also have issues with emotional state when you're feeling depressed, anxious. And so when I speak to kids about it, I said, well, you have no friends, you have no attention or creativity that's taken away from you. You don't sleep as much, you feel tired, and of course you feel irritated because you don't sleep much and from all the exposure. So which one of these four you like? I don't see any good in it.
Yeah, and I think for the audience, it might be really interesting to talk a little bit more of the importance of the default mode network. Like, when does it occur and what's its purpose?
It's a great question.
I know we don't fully know, but we know it's engaged during sleep and also states of boredom.
Correct.
So that is the sort of ground with which creativity does occur.
Yes, that's a very important space, actually. And Dr. Arthur Brooks from Harvard talks about this issue of lack of boredom and challenges parents and families with a really practical challenge, which is to create a space in which you are bored for 15 minutes a day. Do absolutely nothing. They did similar experiments in Harvard in which he describes people closed in a room when there is nothing to do except one button, if pressed, creates painful electric shock. And people still press the button because they can't be bored. Mm-hmm. So creating that state of boredom is where the creativity grows. That's where the innovation comes from. The ability to have that sustained attention for a longer period of time or start shorter, 15, 20 minutes, is absolutely invaluable.
And so if we can think about it as a kind of starving of the default mode network, the starving of the sort of ground of the house of creativity, so to speak.
Yes.
Why? Why is that happening? What's the incentive that tech companies and maybe even smaller companies have to pull from that for our kids and from us? What's your kind of thoughts and theories on that?
Yeah, I think these tech companies are designing apps for attention seeking, attention grab. And I like to remind kids that time is the most valuable resource in our lives, because we all have the same amount of time. We need to be mindful of how we use our time. And nowadays, I think the biggest currency in the digital world is the attention. So tech companies sell apps, and if the apps are free, the cost is attention. They take your attention, They have a very well-designed algorithms that increase engagement. They're not designed for development or for cognition. They're designed for engagement. And with that engagement, particularly in younger kids, we have a host of issues and different branches of this attention economy. One is video gaming. It's not like video gaming we played, where you have a game and you just play a game. There is now a notion of virtual currency and skins and social interaction that requires actual subscription. So that's extracting revenue from the gaming. Similarly, influencer type profiles that are targeting youth, promoting instant reward and easy ways to monetize talent or whatnot. So we are seeing more of these that are deeply embedded into digital environment surrounding interactive electronic screens.
And if you think about this, one from your work and certainly some of my work, where the cognitive neuroscience and AI come together, we are also involved with building a world that might be even closer to an idea of maybe not attention, but certainly a certain level of control. We hope we want the control to be in the hands of the users. What we're now talking about is that actually the control is in the hands of the builders, in this case, mostly larger big tech. And so when we think about what might be steps forward to, one, protect our kids, but also to give our kids the tools to think through this world, do you have any thoughts there? And I'll tell you a story about my daughter in a minute, but I would like to hear.
I think the control and tool are really good words. And I also advise kids that with any screen experience, I ask them, what are you trying to accomplish? Is your device a tool, or is it the master that feeds you random scrolls designed for attention, and time passes without you even knowing what to do? So it impacts deeply relationships, because see, conversations take patience. Scrolling does not. Developing friendship also takes time, and digital feeds are the opposite. Also, developing deeper relationships and friendships requires some level of discomfort. We may have disagreements and learn how to problem solve and resolve conflicts. Digital world is designed to avoid it. So those are real issues that we need to ask, and just come back to that fundamental question: is the device a tool? And are we purposely using the tool? We should have better tools. Like over the history of human civilization, we always wanted to create better tools from the Stone Age. Computers, nobody complains that computers got faster. We need fast computers. But now the tools have changed, and particularly 2007 when iPhone and smartphones came about, but when the App Store came about in 2008, and then we have a FaceTime 2010. A lot of good uses of these social features, connecting people, but then that's where the apps came that require attention. So we're talking about last 15 years, which is maybe half a generation of human experience, that this technology and this new digital interaction has exploded into our daily lives.
And it's very hard for kids as a parent, it's very hard for me to tell my daughter, in essence, I'm the regulator, right?
Yes.
And you can have a teen listen to you or not. Often teens may not, because they're trying to find their own way, and you want them to find their own way. And there's a cost in the digital ecosystem here of them finding their own way. They may not. And so as a parent, you're negotiating that idea of this single thing. I want my kid to internalize, not to just take from the outside in as a command, as like, you better not do that from parent, but to actually internalize this, I don't want to do this now. This is not good for me. Or, that they understand the difference between the tool and the master, as you describe it. My daughter came to me, I don't know, it was a month ago, and she brought an iPad, which I told her it was a limited time, and she brought it to me, and she was handing. I said, "What are you doing?" She goes, "I want you to take this, Daddy." And I said, "Okay, I want you to take this and hide it from me." I said, "Okay." She goes, "It's hurting me. It's hurting my brain. Take it. I don't want it." And she walked quietly away. At that moment, I realized that she was starting to turn a corner of something she felt. She didn't just take it as a command from Daddy or Mommy, but it was something that she was learning to negotiate. And I think this is really hard for all of us as parents, as technologists, as scientists, is to see our kids having to go through something we're not sure they're going to arrive at. We do the best we can, and then you see the overwhelmed parent. They just don't know what to do, And I am both those parents. I am the overwhelmed, and I am trying to guide. And I don't know where you come in on that, but I just wanted to share that as a real living story of seeing this negotiation going on for our kids, and they don't have a lot of guidance. I mean, they have our guidance, but they don't have a lot of external guidance, from the tech world. They just have more apps.
More apps.
Yes. And I find this very, very, very difficult, but also very part of our time. This idea that the kids are in a wild west of attention that's focused so much on grabbing them, and they're still developing, But anyway, I wanted to share that with you.
Yes, that reminds me of a real issue that childhood was a local issue previously, when you play with kids from your neighborhood and real interactions, and now it's become like more global, digital world with people that you don't even know, and fairly unregulated, unstructured, designed for attention grab.
Mm-hmm.
So that's a big danger that I clearly see. And yes, I'm in a similar position to both try to regulate and educate kids. Kids don't need perfect parenting, but they respect clear boundaries.
Mm-hmm.
So, like you said, there is a control layer, various applications that we can use as parents. I use Custodio application, which allows me to regulate which apps are used for how long, and also warns me of any potential risk online. And one thing I was really surprised reading 2025 annual Custodio report, which is titled Lost in the Scroll, where I realized that it's not just a local problem, but it's a global, worldwide problem. The report revealed that TikTok usage grew 50% year over year from 2024 to 2025, and amounts to 2.2 hours of daily use across the world. And now, as we talked before, not all media or electronic content is the same. Movie experience of an hour and a half to 2 normal life speed is equivalent to about 10 or 15 minutes of interactive screen. So if you think about 2.2 hours, that really makes you think. So easy solution for me was completely disable TikTok. The next tallest pole in the tent is the Instagram. So TikTok, Instagram, removing the algorithmic feature from YouTube. And I even deactivate YouTube on devices and tell kids we can watch YouTube only as a family, and we follow the 3-step process. We want to learn, We search, watch, and close. We do not let the program overtake control and end up impeding on our time and ability to learn what we actually came to learn.
And how has that gone?
It's gone surprisingly well. You may think like removing screens for kids does have some pushback, but at the same time, surprisingly, after a day or two, they don't complain even. What could be endless digital immersion turns to be, can I have 10 minutes just for communication? And 10 minutes is 10 minutes. They do other things. That's where this internal creativity comes in, and comes back to this earlier observation that attention is the most important, particularly in children, because they're still developing their emotional regulation, executive planning, and cognitive awareness. If we think about brain development from prenatal, newborns, and over all the life cycles, it kind of goes from the back of the brain, from occipital lobe, visual cortex, and then you go through the kind of the mid areas with somatosensory cortex, learning to walk, learning coordination. But the frontal brain is in the later stages of development. So through childhood and teen years, that's kind of an early stage still of the frontal lobe development that continues well into the adolescence. So when kids have this interactive screen experience, particularly, let's say, video gaming, they engage into this visual and motor loop, which sometimes is called fight or flight response, where they just engage into high dynamic content without any notion of perspective and thinking about that executive functioning and emotional regulation. It's pretty scary, especially when they're connected together and in that state of mind, buying another skin or submitting to some peer pressure for more tokens and things like that. How come I don't have it? Is pretty dangerous.
And really what you're saying is that as the executive function builds over time, the kids are already very early in to this kind of impulse related responsiveness, interactiveness. And so it's in essence bypassing the executive function. Is that
That's
what
correct.
you're saying?
Yes.
And then therefore potentially that executive function and many other visual and sensory functions may not be integrated in a way that is beneficial to the person actually growing up, sort of fully developing. I'm just throwing that out as a possibility that this bypassing is not innocent.
Correct.
It actually has an impact. And I always think that, being in sixth grade again comes only once.
That's right.
Being in seventh grade comes only once. So we're at a certain age only once. And during those periods that we're at those ages, tech is there, like in a major footprint. And they're not so concerned about what seventh or eighth grade is. They want you then there, So it is something that I see parents very overwhelmed with. They don't have this level of discussion, but they are having, they're raising a device and a child.
That's right.
They really are, and yet they have no control over the device in the sense of how it is. It just continues to have an influence in the family dynamic. That's when it started to really come to me, is that the actual tantrums and concerns and over emotion of, let's see, my daughter and other kids, when you took a device, it just was so out of, like, what's going on? This was so out of keeping to who they are. And so that device dependency and the blowback of not having it was very disturbing to me, like some years ago. And so it's like, that's what brought it to my attention, was just a very intimate sort of family situation, that there is a problem here. Now I knew there was a problem, but to see it living in front of you, that dependency turning to rage is remarkable. And I'm sure I'm one of gazillions of people that have seen it. You've seen it. I want you to go, maybe if you could, Dejan, and talk about, a lot of people are more and more talking about a kind of digital fast. Why a digital fast, and is it effective? It seems like you kind of got into that, or you sort of stepped into it with your family, and you see other parents and technologists do this. Does it work?
It does. I got an idea from this book, Resetting Your Child's Brain by Dr. Dunkley, where she speaks of a simple non-pharmacological intervention, which is 4 weeks of digital fast. For younger kids, that's easier to do because they do not have group chats with their coaches and other things that high school kids, for example, do. But the recommendation is 4 weeks of a complete digital reset, no interactive electronic screens. So you can still watch a movie as a family, but no interaction of like video gaming, social media apps, and all the things where control is being given out to the outside world. That seems to kind of promote transition into that creativity space. Immerse with the analog world. Do read books, actual books. In fact, that was an interesting, maybe kind of a digression a little bit, but schools that use tablets or computers in their reading, their kids perform at the lower reading level than just reading paper books. So removing them from that digital world does indeed dramatically improve their quality of sleep, focus, the ability to execute a task, to have that sustained attention from start to finish, and just be kids and have fun. You enjoy a lot more interaction with your kids.
I want to ask you, so you have this also wonderful perspective, because you're in essence training the next generation of scientists, right?
Yes.
And so you're now training scientists that have been part of this ecosystem, digital ecosystem. And are you seeing training them now versus maybe 10 years ago, or any different? Or is there any other tactic as an educator that you need to use? Is their attention less? Their cognitive performance less? I mean, I just wanted to have a sense.
I think I would use the key word engagement. I did notice and kind of had to think about strategies to get students more involved, because when I started my teaching career, we didn't really have laptops as a regular classroom item, tablets for note-taking, smartphones, so the list goes on. And I used to think, how do we really do this to motivate students to engage and really the value the content and invest their time in the lecture? So I kind of capitalized on that word engagement. So I tell students, I really can be the most effective teacher if I know what you understand. So I need to hear it from you. And I try to create a classroom environment in which I interact with students. So I try to take over interaction from their side tasking with the phones, and I tell them that it's not beneficial to have distractions and it's for their own good. And so that kind of really I found to be productive. But I do recognize the challenge, just because, again, environment changed. Same classroom, but we had no digital distractions in the past as much as we do have now. And students back then were a lot more interested in figuring out difficult problems, reading extra literature from the library, having deeper discussions than the constant immediate reward cycle type of users that we have today.
And so, like, if we, I love this, I love all the conversation. I love this part of it, because we're talking about not sort of a dystopia of childhood. We're talking about like, we're in it and we're making the world a better place, finding ways through, in this case as an educator. And are you also seeing, in terms of you kind of taking on that engagement as an educator versus letting the engagement roll over your students, with distractions? Are you seeing, young physicists, young technologists, engineers, using the latest, let's say, Anthropic Codex or ChatGPT to do their work, and how are you negotiating that if that is occurring?
Yeah, I am a type of instructor, educator who, again, likes to explore new tools and technologies. And in fact, I encourage my students to use ChatGPT to write code for chip design and development. Because oftentimes when you write, this is called RTL, or register transfer level, it's kind of really special language. For complex designs, it can become repetitive, making sure that you have all the right modules and descriptors. You need to realize, to understand the structure. I tell them, you understand the structure of the code, what you're trying to build, and create guiding prompts for ChatGPT or other tools that do all the manual repetitive work for you. And you are accountable for the outcome that you get. So I'd like you to explore ChatGPT as a tool. It's really good for coding. So I do absolutely encourage them. I don't think we should hide away from that, because we do need more productivity as semiconductor technology advances still rapidly, and semiconductor systems become more complex. We need to understand how to create abstractions that are manageable. And in that sense, these productivity tools can be very helpful.
And I mean, I love that because there's so many, almost a binary discussion around using vibe coding and other types of approaches to physics level LLM use, and going back to your earlier comments about like kind of the master or tool, you're saying, please, let's use these, let's get rid of the repetitive work, so you actually can do the more creative thinking to design something maybe novel. And I think that's a real big encouragement from an educator, but also I think from parents that may see this as that the tools will be adopted. It's how you adopt them, how you integrate them into your life, that's so important. And I'm a very pro technologist in many respects. I share that with you, but I also know that there is an unequal adoption and understanding of these tools, and therefore, if there is a misunderstanding, a lot of people can be captured as opposed to using. They become used. And I think that is part of the theme that we're talking about, is making sure that you are actually using and engaging as opposed to being an object of engagement.
That is absolutely right. I agree.
Yeah. And maybe as you cross these different worlds, as an educator, as a parent, as a really concerned citizen about the kind of attention that you see as being harvested from our kids, do you have any advice for parents? You've given some wonderful advice, but do you have any thoughts about sort of maybe general thoughts about how to bring up a device and a child at the same time? Because the devices are not going to go away, and we're going to continue to have kids, right? So I'm putting you on the spot. I'm sorry.
Yes, I think that's a great question. I think we need to start from ourselves, because we are not immune to the fragmented attention that comes from devices ourselves. There was a study that showed that adult now has 47 seconds of attention span in the presence of heavy use of digital media, which is probably why TikTok clips are about 45 seconds these days, as compared to 2012, where our attention was 74 seconds, almost double. and a few decades ago of 150 seconds. So we are kind of going into the decline. So which says, well, we need to really understand the problem ourselves and practice good digital habits. Have allocated time where we manage our communication, because we do not need to be always on or instantly respond. Um, and just really modeling that in front of our kids is what they see and how they would behave if we as parents are on our devices. What are kids going to do? Say, well, can I have mine, and so on. And so modeling good behavior is really goes a long way. And then enforcing a communication and technology structure at home. So for example, no phone or interactive devices after 7 o'clock. We can maybe watch a movie and still at least hour or hour and a half before bed, even movie should end, just to give that quiet time to kind of wind down and limit the time use, and always ask a question. Okay, now you're going to use your device. What are you going to use it for? Mm-hmm. To log into a meeting, to call a friend to meet, or again, comes down to, is it a tool? How are you using this tool? Understand, it's just that.
And the modeling of adults to children in this digital environment is so lost sometimes. Like, we're on the phone saying, "Okay, please, could you please get off?" And I think we don't even see ourselves sometimes, and that self-awareness is really critical to breaking through in the way that you're describing. Sort of reclaiming that engagement for the family, for the kids, for the creativity, for that default mode network, so that we as a family can be creative, right? It's not just them, it's us and all of us. And I don't think parents often do a good job of that. We try, but there isn't a lot of guidance, except maybe this podcast and some other things, to say, look, we know that we need to be better at modeling behavior. We know that that's where it all flows. And in fact, it flows back to. So if the kid is struggling and they see mommy and daddy just like breaking all the rules, it's just like the learning doesn't happen. The change of behavior doesn't happen. So I think that's a wonderful message to leave people with, that we need to be our better selves as we expect our children to grow and become their better self. And I mean, that's a timeless thing, we all need to do that. And so if this problem we've sort of circled around today of attention and cognitive development, emotional development in this digital ecosystem can be really felt, one of the things is that we have to be better modelers, and we have to be super attentive that we're raising a child and a device. I mean, the devices are not going to go away, and we have to be responsible both in our own lives but also in our children's life. And, I think people are dawning. You see people are dawning in terms of understanding this, but from psychoanalysts to technologists to policymakers to attorneys to tech leaders. I mean, I don't know how many lawsuits are being talked about as we're having this podcast right now.
Yes, that's right.
And there's all different sides arguing for their position, but this discussion is going to go on, but ultimately it's down to us, as parents, as adults, to model, regardless of however the courts decide, what is the proper behavior, because that's what our family leaves with when they grow up and move on. And that's the students that come into your classes. They're coming in with some aspect of how the parents modeled that those digital habits, and so it impacts you. It has so many downstream effects. If we get this right, how learning improves and cognitive performance and emotional development improves. How we get it wrong, how all of those things get disruptive. So it's such an individual choice, but also individual effort to make that modeling work. And we're coming up with new ways of doing it, right?
Yes.
The books and all of this. So, Dejan, I want to thank you for just a very insightful and important discussion that we've had today And I hope it makes people feel they're not alone, and also that there are people really working both on more intimate family areas, but also in the technology and the computer science that have the shared concerns there. And so I want to thank you.
My pleasure. And I would encourage all families to just go and do it. Establish a structure that brings the joy and all that wonderful family dynamic that we are all missing, hiding behind the screens.
Great. Thank you very much.
My pleasure. Thank you.